learners. Welcome to the online course on electricity and electrical wiring. We are going to discuss lecture number 27 on types of earthing and their advantages and disadvantages of module 9 on earthing. In this previous lectures of this module, we have learned earthing and its requirement and process of earthing and soil resistivity. Today, we are going to discuss an important topic. We will discuss different types of earthing processes. Understanding earthing is crucial because it helps us protect both electrical system as well as our safety. We will explore the different types of earthing, their advantages and disadvantages, and some key terms that are often used in this context. Let's start by asking a very basic question. What are the different possible types of earthing? What are the advantages and disadvantages of different types of earthing? As we go through this lesson, keep this question in your mind and feel free to share your thoughts and experiences. The main objective of this lecture are to enable the students with the understanding of different terms used in the process of earthing. Second objective is to improve the knowledge on different process of earthing and hence to learn about the procedures to install such earthing. Thirdly and lastly, to learn about the advantages and disadvantages of different types of earthing. Let us start this lecture now. Before going into different types of earthing, let us have a look at different terms used in this process. So first, I'll talk about earth and ground. This is a wire connecting the electrical system to a plate on the ground, and in North America, this is more typically referred to as ground as per the National Electrical Code. Now another term very commonly used is earthened or grounded. An electrical device, appliances or wiring system is said to have been earthened or grounded if it has been connected to the earth with the help of an earth electrode or a ground rod. Another term is solidly earthened. So solidly earthened refers to an electrical system, appliances or device that connects directly to the earth electrode and that doesn't need a circuit breaker such as fuse or any other form of resistance. Another very important term is grounding electrode or earth plate. The ground electrode, it might be from copper ground rod or conductive earth plate. So it is a conductor placed in the ground in electrical earthing system. Conductive plates such as rods, metals, water pipes or any low resistance conductors can be used as earths. Another very important term that is very much used in this context is earth resistance. What is earth resistance? This is the overall resistance between earth and the earth electrode. Okay, so just keep in mind the earthing must follow the NEC. NEC means National Electrical Code and IEEE, that is Institute of Electrical and Electronics Engineers standard to warranty electrical safety. Metal cover casing of GI pipes and switches around electrical supply lines. Every appliances should be earthen. Earth point on 3-pin plugs, sockets and outlet shall be bolted to earth permanently. Apart from this, the frames of generators, stationary motors and metallic part of a transformer must be provided with 2 separate earthing. In such a system, the center conductor is earthen in the generating station to stabilize the voltage and hence increase safety. In the case of overhead lines, stay wires, one end of at least one strand is bonded to the earth wire to provide a safety path of lower impedance to ground in the event of stray current or lightning strike to reduce the chance of electric shock to the public or any other person or animal. A complete electrical grounding earthing system consists of the following three very important components. First, earth continuity conductor, earth-in lead, and earth electrode. So let's discuss about these three components one by one. The earth continuity conductor, or just earth wire, is super important for safety in electrical system. Its main job is to connect all the metal parts in a building. This includes things like conductor, switches, and the metal cases of electric motors and transformers. By connecting all these parts, the earth wire creates a safe path for any stray electricity, which keeps everyone safe if something goes wrong. Next point is earth-in lead. The earth-in lead is also known as the earth-in joint. This part connects the earth continuity conductor to the earth electrode, which is either a copper ground rod or a grounding plate. The earth-in lead is key because it provides a safe path for fault currents to flow away and safety continues. For it to work well, you want to keep connection to a minimum, make them small, and keep them straight. Copper wire is often used here because it can handle more electricity. If you have high installation, copper strips are a better choice. Hard-drawn bare copper wire can also work as an earthing lead. It links all the earth wires to the electrode. Now the third term about which we are talking, that is earth electrode. When setting up an earth electrode or plate, it should be installed vertically in the ground, surrounded by a layer of charcoal and lime that's about 30 centimeter thick. A good mix ratio would be 1:3, like using 1 kg of salt and 3 kg of charcoal. This mix helps keep the moisture level high around the electrodes. So why use copper rods? Because we are already discussing many times copper. So why to use copper rod in earthing system? Copper is a very good choice for an earthing system as it carries electricity very well. Copper also doesn't rust, so it keeps doing its job over time without degrading. It is being strong is suitable for different climates and soils. As it's a good conductor of electricity, it can carry away the fault current easily to the ground. Plus, copper rod can last a very long time in the ground. Another big plus for copper is that it doesn't waste much energy converting it into heat. It usually meets building codes better and is seen as very reliable for grounding purpose. So use of copper is a good idea in a grounding system. The kind of safety, strength, and efficiency copper offers, no other material can ever provide to date, to my knowledge. Let's dive into the different types of earthing now. Earthing system can be differentiated into several different types based on its unique applications. The most popular kind of earthing system includes plate earthing, pipe earthing, and rod earthing. And there is another one that is also known as maintenance-free earthing. We'll be discussing them in this lecture. While discussing different types of earthing, we will discuss the different components, the procedure, and the advantages and disadvantages of each specific type of earthing. Let's delve into the details of these four processes of earthing. First, let us discuss plate earthing. So plate earthing is a widely used method that involves varying a metal plate typically made up of copper or galvanized iron, which is also known as GI, in the ground. The primary purpose of this plate is to provide a low resistance path for electrical current to safely go to the ground. That means safely dissipate into the earth. The standard dimension for the plate are generally 60 centimeter times 60 centimeter times 3.18 millimeter. So in feet notation, if I say, it will be 2 feet times 2 feet times 1/8 inch for copper. So this is a very specific configuration given for copper. And for other GI, the specification is like 2 feet times 2 feet times 1/4 inch. So that is, let's say, for any other GI. So it is important to vary the plate at least 3 meter or 20 feet below ground level to ensure its effectiveness. Components required for plate earthing are earth plate, earth pit, earthing wire, moisture retaining material, and watering pipe. Moisture retaining materials such as charcoal and salts are used to enhance conductivity. A GI pipe is actually placed near the plate to provide water and maintain moisture level. Now let's discuss about the working principle. The metal plate is embedded deep within moist soil to ensure continuous contact with the earth. This allows electrical faults or leakage current to be safely discharged into the ground through the plates. Corrosol and salt are used to retain moisture, as I said already, and enhance the conductivity. A wire connects the plate to the electrical system, ensuring effective grounding. Now, what is the procedure for doing plate earthing? To set up a reliable grounding system, a copper or GI plate is buried vertically in the ground. A hole 2 to 3 meters deep is evacuated to maximize soil contact. Around the plate, a 30 centimeter layer of charcoal and salt mixture in a ratio, let's say 1 to 3, is applied to improve conductivity and to retain moisture. The earthen lid, which is a copper or GI strip, it's generally of 6 millimeter square, or it can be go up to 25 millimeter square. So it is securely attached to the plate and extend to the surface. A GI pipe or watering funnel is installed to help maintain moisture. After the setup, a brick chamber with a cast iron lid is constructed at ground level for maintenance and inspection. The pit is then filled with soil. Ideally, the earth resistance should be less than 1 ohm. To improve conductivity, more water, salt, or charcoal can be added to the earthing system. This effect is one of the best, as it can make humans safe as well as the instruments by efficiently removing fault current from the system. Now you can ask me, why moisture matters? Moisture is crucial for improving the performance of electrical system. When the soil surrounding a grounding plate is wet, it reduces electrical resistance. As a result, in the event of an issue such as power surge, electricity can flow away more easily. So keeping the ground moist makes the grounding system more reliable and efficient. So how we protect our systems at our home? So to keep everything safe, we cover the copper wire in an earthing system with a special insulating pipe. This covering protects the wire from damage and stop people from touching it. So it's a simple but smart way to ensure safety. Now let's talk about the advantages of plate earthing. Plate earthing is a solid method for keeping electrical system safe. It gives excess electricity a safe route to the ground, and this helps prevent electric shocks and protect both people and devices. Plus, it helps to keep voltage level stable at the home. So this is important because sudden jump in electricity can damage appliances. So by keeping a low resistance path for fault current, plate earthing system reduces the chances of electrical damage. The system is really useful for big buildings and heavy electrical setups like factories or shopping centers. In these places, safety and stability are very crucial. A good plate earthing system not only boosts electrical safety but also help appliances and wiring long lasting. So maintaining this system is key to getting the most out of our electrical setup. So what are the disadvantages of plate earthing system? Despite its advantages, plate earthing has significant disadvantages. One main downside is that it is more expensive than other earthing system since it requires expensive materials such as copper or galvanized iron plates as well as professional installation. Furthermore, it requires frequent care to keep the surrounding soil moist, as dry soil can increase electrical resistance and hence decrease efficiency. Again, the kind of earthing may not only suitable for locations where the soils are very resistive or rocky. In such a scenario, we have to avoid installing this plate earthing system in such locations. Dear learners, it is now time for a self-check of what you have learned so far. Please attempt the given questions. Now let us again discuss about pipe earthing. So pipe earthing is another grounding method that safely releases fault current into the ground. A galvanized iron pipe is buried vertically in a pit filled with salt and charcoal to enhance conductivity. The pipe is perforated with holes to improve moisture absorption. So now what are the components of pipe earthing? Components are galvanized iron pipe, earth pit, charcoal and salt, earthen wire and watering pipe. A galvanized iron pipe of 2.5 to 3 meters long with a diameter of say 40 to 50 mm is required where the lower part is perforated. A pit dug at least 2 to 3 meters deep for the GI pipe. To increase conductivity, charcoal and salt are added around the pipe like we have already discussed in the previous case. A copper or GI strip that connects the pipe to the electrical installation is also required. Now, how this pipe earthing works? Pipe earthing is an effective method for ensuring the safety of electrical system. It directly strays electrical currents deep into the ground. The process begins with digging a deep hole which should at least have 3 meters deep. This depth is important because deeper holes retain moisture more effectively, and moisture is crucial for optimal electrical conductivity. Next, we put a GI pipe into the hole. The pipe usually, as I said, has a diameter of 40 to 50 millimeter. It stands tall in the pit and has holes all around it. These holes helps the pipe connect directly with the soil, and it helps keep it moist and reduce resistance. Less resistance means it's easier for those stray electrical current to flow safely to the ground. The earthen wire gets attached to the pipe using holes that we have to drill on the pipe. This makes a strong electrical link. We also make sure to securely bolt and clamp everything together. This will help to reduce the resistance as per the requirement. Once the earthen wire is in place, it's time to fill the hole with soil. We use salt and charcoal in layers for this process. The right mix is 1 kilogram of salt for every 3 kilogram of charcoal. This combination helps the system conduct electricity better and makes the earthen system last longer even in dry ground. To keep everything working well, we need to keep the area moist. Now let us discuss about the advantages of pipe earthing. So pipe earthing is an inexpensive way of earthing electrical system at home and industries. It intends to safely bring down the excess electricity through mitigating the chances of shocks. The installation is simple and requires less space than plate earthing. Hence, instances where this procedure comes in handy include wet region, as the metal pipe will absorb moisture from the soil. Now, it has also some disadvantages. Say, some disadvantages always exist. Okay, its performance is dependent on soil type. For example, if the soil is dry and rocky, then it will not work very well. Rusting is yet one more point to consider, in that metal would practically corrode on such soils, and this might require it to be repaired or replaced quite steadily. But due to intermittent moisture, one might have to water it from time to time to maintain its effectiveness. Let us now discuss about rod earthing. Rod earthing generally denotes the rod, often copper or galvanized steel, driven into the earth. The rod is the primary conductor dissipating electrical current into the earth. Many items are required in this installation of rod earthing at a site, such as earth rod, earth wire, clamp, connector, soil enhancer, a watering pipe, and earth pit chamber. So how this kind of earthing works? Let's discuss about that. The fundamental importance of highest conducting capacity along with highest corrosion resistance should be considered while selecting this rod earth, which should be made of copper, GI, or stainless steel. Such rods are generally of 1.5 to 3 meter in length and 13 to 25 millimeter in diameter. The rod can be hammered or forced directly into the soil or set into a hole of around 1 meter deep for better moist soil contact. Activating surrounding areas of the rod with charcoal and salt will assist in moisture retention and will increase the conductivity as well as decrease the soil resistivity. To enhance the efficiency of grounding, regular watering may be required in this process. A copper or GI wire of 6 mm square to 25 mm square is tightly coupled to the rod to secure an effective fault current path from the electrical appliances into the earth. So what are the benefits of this kind of earthing? So earth rod or rod earthing are cheap and simple to use in ground electrical system. They are space saving and easy to install and are among the best grounding system for homes or industries. They are made from copper or galvanized steel, giving them good conductivity and longevity, especially in favorable soil conditions. The good thing about this earth rod is that they provide a low resistance path for fault current that helps in protecting devices during any lightning strike or voltage spike. But there are problems associated with rod earthing also. The most important drawback is the condition of the ground. For installation in rocky and resistant soil, it becomes harder and less conductivity is obtainable, which means that several rods would need to be installed, costing more on this system. Another problem is corrosion, especially in acidic or salty soil, which might lessen the breaks occurring in the rod or needs to be replaced. Some soil types might be dry and in those areas and thus might not have sufficient moisture for proper grounding. Therefore, extra moisture like regular watering or chemical treatment has to be taken care of. Finally, we'll talk about maintenance-free earthing. Maintenance-free earthing is an advanced and efficient version of traditional earthing method. This method involves using specialized electrodes and components that require minimal or no maintenance. So in this process of earthing system, it starts with digging to create a pit according to the manufacturer's specified dimensions to accommodate the electrode and backfill materials. To enhance conductivity, a special compound is prepared. Then the electrode is placed in the pit and the compound fills the pit hole, thus reducing the soil resistivity. A protective lid is placed over the earthing and the earthing wire extended to the ground level, resulting in a very reliable grounding system. Some advantages of this maintenance-free earthing are as follows. It reduces the frequency of check and maintenance, entailing very little upkeep. It provides long-lasting reliability and efficiency for the safety of personnel and equipments. Also, it is very compatible for many applications. And some disadvantages I also would like to mention, but such systems have disadvantages such as increased cost due to specialized materials, and they are manufacturer dependent. Hence, repair costs become excessive. Charges might entail digging, increasing labor expenses. In extremely dry or rocky soils, these compounds performs very poorly. So, these are the few disadvantages we have to keep in mind while installing this kind of maintenance-free earthing. Now let us talk about applications of earthing system. The earthing system have a very significant role in different sectors. It dissipates the fault currents to the ground. So it saves household buildings. First, let's say, now again enabling the running of machines in different industries, reducing the electrical risk in commercial buildings, catering to the gigantic electric loadings in a power station and substation, etc. So it helps keeping all these instruments, industries, building safe at the same time by reducing the fault current efficiently to the ground. So to conclude, earthing is an essential part of any electrical system which very well protect peoples and equipment. Earthing systems are essentially of different types, as we have discussed: plate earthing, pipe earthing, rod earthing, and maintenance-free earthing. Each method has its own advantage and is selected on the basis of soil resistivity, cost, and specific safety needs. Well installation and maintenance of earthing systems are of strong importance to ensure the safety and reliability of electrical installation in order to avoid failure, fire, and any other such hazards. Good earthing practices will ultimately bring about energy efficient and safer electrical environment to improve the overall safety and performance of our electrical system. Dear learners, it is now time for another self-check of what we have learned so far. So please attempt the following questions. I hope the information shared in this video has helped you further enhancing your understanding of distribution panels. Thank you.